Hello and welcome, dear friends of protection and control engineering. Comparison is the death of joy. Taking this knowledge into account, we don't want to compare Omicron Ct Analyzer and MEGGERS MVCT today, but introduce both devices in a practical test. In the end of the video, each of you can get its own idea of which device is the best for their own purpose, and we all remain the inherently happy people we are. Enjoy the video and let's get started.
In the first step, we briefly introduce you to both devices and then show you what experience we made in the determination of the magnetization characteristic and the knee point voltage, in the analysis of the accuracy limit factor ALF, in measuring the ratio, and with the respective software supplied with the devices. At the end of the video, we perform the famous green Meadow test. For this, we imagine the following situation. We walk with our partner in a forest. Suddenly, we find the current transformer along the way. Unfortunately, the nameplate was previously scalded with coffee by an industrial engineer so badly that it has become illegible. We can tell what kind of CT it is, so we carefully take it home and try to determine the CT parameters of this current transformer. We start by presenting the Omicron Ct Analyzer following the natural order of the alphabet. The Ct Analyzer, which I also like to call the Miracle of Bern, is a device for testing, calibration and evaluation of current transformers. It weighs 17.4 pounds and the dimensions are just 9.2, 7.2, 3.7 inch, and it's almost as tall and wide as the Compano 100 and even slimmer in depth. The display is about 4.92 and 2.76 inches tall and always shiny clean since it's not designed as a touchscreen. The operation is done here via the buttons of the front panel or alternatively via PC or laptop. The power consumption of the CTA is 500 VA, the maximum output power is 400 VA effective, and the startup time of the system after switching on was about 11 seconds in our test. The application range is between 16 and 400 Hz. This covers every possible application from railways to aviation. Due to secondary testing, it doesn't require heavy cables on the CT Analyzer, which would otherwise be required for high ratios or high knee point voltages. The low voltage measurement method works here because of a smart lowering algorithm of the frequency during the measuring process. The following tests are generally possible with the CT Analyzer. The measurement of the CT and the connected burden. Determination of the remanence. Determination of the winding resistance. Measuring of the magnetization characteristic and the knee point voltage. Analysis of the limit accuracy factor ALF at nominal and operating load. Measurement of the transmission ratio of the polarity. And even measuring of unwounded current transformer cores under using a special cable. In addition, the CT Analyzer can be used to calibrate CTs. The CT Analyzer automatically detects all relevant CT values and compares the results with the selected standard. The device evaluates the current transformer according to IEC 600441, IEC 600-446, IEC 618692, IEEE C57.13 or national or self-defined standards within a few seconds at the touch of a button. The knee point voltage can be determined from 100 millivolts up to 40 kV. Once the test has been completed, the current transformer is demagnetized as standard by a test routine. All measurement results can be transferred to a laptop and automatic test reports are generated. These can easily be switched between many languages, regardless of the language in which the measurement was taken. The following languages are available: Chinese, English, French, German, Korean, Polish, Portuguese, Russian, Spanish, and Turkish. This means that the Korean-speaking Portuguese is always able to create and submit French language test records to a client in La Rochelle. This greatly simplifies the international business. If the test is performed from the laptop, the nominal data are conveniently entered to the computer via keyboard. After the measurement has been completed, the data are automatically transferred back to the laptop and saved in a report template. In addition to the already mentioned test functions, there are further possibilities. An ingenious function of the CT Analyzer is the possibility to simulate different burdens. Whenever a change in burden affects the accuracy of the measured CT, the CT Analyzer can easily calculate the results for different loads and primary currents after a single measurement. Furthermore, the CTA has an integrated software multimeter with which manual tests can be carried out. Here, ohmic and inductive resistances or impedances, as well as polarity and burden, can be measured. In addition, Omicron does not do much advertising with it, but the CTA is easily able to determine the ratio of inductive voltage transformers. Thanks to the existing and accessible user interface, users can also program their own test programs and design their individual test routines and integrate the device into automation systems. A handy list of optional accessories is also available, such as the CT SB2 switchbox for the testing of multi-tapped current transformers, with which up to 6 taps can be tested at the same time. The C-Pol2 polarity checker for directional testing. The multifunction transport case, which can be converted into a table within seconds, or the practical trolley that can be thrown over the shoulder for spontaneous club visits. So much for the basic profile of Omicron Ct Analyzer. Let's now turn to MEGGERS MVCT. The MVCT, let's just call it the new Dallas Wonder, is a device for testing and evaluating current transformers, measuring transmission ratio and secondary resistance of inductive voltage transformers, and can also be used for secondary testing of protection relays. The MVCT weighs 20 pounds and with dimensions of 14, 7.5 and 12 inches, it's slightly larger than the Omicron Ct Analyzer. The display is 9-inch wide and 5.7-inch high and may be touched. It's a sunlight readable full-color TFT LCD touchscreen display which is used to operate the device. The MVCT can also be configured to be delivered without the display or operated via a laptop using MEGGERS software PowerDB or MEGGERS proprietary Smart Touch View interface. The maximum output power of the MVCT is 300 VA effective, and the startup time of the Windows-based system after switch on was 78 seconds in our test. Since the MVCT works on a secondary side, No heavy cables are required here either. The following tests on current transformers are generally possible: the measurement of the current transformer and the connected burden, determination of the winding resistance, measuring the magnetization characteristic and determining the knee point voltage, measurement of the ratio and the polarity, and the 1 kV DC insulation test. With a single push of a button, the MVCT performs a CT sweep test and calculates the nominal knee point. The saturation test can check knee points up to 30 kV using innovative DC technology. As a result, almost all types of current transformers can be tested with this portable device. The MVCT calculates the nominal knee point according to IEEE C57.13.1, IEC 600-441, IEC 600-446 or IEC 61869 standards. While the saturation test is being performed, the MVCT records the CT saturation curve on the STVI display and provides the nominal knee point according to the desired standard. Since current transformers sometimes have multiple taps, the MVCT has the ability to record and display up to 10 CT saturation curves at the same time. In addition, for inductive voltage transformers, the ratio, the polarity, the burden, and the winding resistance can be measured. The MVCT also includes a 1 kV DC isolation test system to verify the voltage in current transformers and their secondary cabling. Another extra feature of the MVCT is the ability to test electromechanical, analog, static, and digital overcurrent relays, including voltage-dependent directional functions. Among the testable functions are under and over voltage, single-phase impedance, single-phase power, single-phase overcurrent, frequency, and over-excitation. The MVC test set from MEGGER also offers the option of transferring all measurement results to a PC and generating automatic test reports. Even with the MVCT, it's easy to switch between many languages regardless of the language in which the measurement was taken. The following languages are available: traditionally Chinese, Chinese Simplified, American English, International English, French, German, Korean, Spanish, and Turkish. As an optional accessory, MEGGER offers the Smart Touch View interface. We now want to record the saturation curve according to IEC 618692, both with the MVCT and with the CTA, and use the following two transformers for this purpose. A 10p5 current transformer with a nominal ratio of 200 to 5 amps with a power of 10 VA. Our second CT is an old 10p10 starting CT. It has an exotic nominal transmission ratio of 1.64 amps to 1 amp and it's quite strong with 25 VA. We start again with OMICRONS CTA and first look at the test wiring. Here you can actually do nothing wrong. The correct test wiring is large on the front of the device shown. Even a PhD industrial engineer would be able to make the correct wiring with a probability greater than 50%. We simply connect the output and the secondary measurement with the two secondary terminals of the core to be tested and the primary measurement with the two primary terminals. After entering the nominal data of the CT, We press the start button and the test starts. We were able to get the following results. The 3 measurements of the knee point voltage of our starting CT provided the values 217.09, 217.18 and 217.3 volts. The measurements lasted approximately 45 seconds each. It should be noted that the CTA performs all measurements including demagnetization within this time window. The results for remanence, resistance, ratio and an assessment of the measurement results are also immediately available. Only the measurement of the operational burden we had deactivated in advance since we had connected no secondary circuit. The CT Analyzer also immediately outputs the accuracy limit factors ALF for the rated and operating state. In our case, the calculated design accuracy limit factor is well above 13 for each measurement. The magnetization curve is displayed graphically and can also be scanned with a cursor. For the second current transformer, we were able to measure the knee point voltages of 10.95, 10.96 and 10.96 volts. The measured ALF was higher than 8. The results seem plausible on the nameplate and the scattering of 3 measurements carried out is negligible. Now let's take a look at the MVCT measurements and start testing again. Again, you can't go wrong. The test circuit is also shown on the device and the sublight test cables are all clearly labeled. However, the MVCT is not connected to commercially available test stripes, but with a special MEGGER connector. This has the advantage that you have to think even less when connecting to the device, but you cannot easily replace a defective test cable from the standard cable case. The measurement of the saturation characteristic can be easily started after we have entered the nominal data of the CT and the corresponding test options. After a measuring time of 100 seconds each, the following results are available. For the startup CT, we were able to get knee point voltages of 216.13, 213.199 and 220.33 volts. In this measurement, only the magnetization characteristic of the device was determined and processed in a beautiful graphical representation. We could not determine the limit accuracy factor ALF with the MVCT. We searched the entire manual and all device options afterwards. On request, we were informed that the MVCT can be used to determine the accuracy limit factor, but only within the scope of the test for the identification of the nameplate. For the second transformer, our measured values were 11.77, 11.79 and 11.69 volts. Now let's take a look at the measurement of the ratio and start this time with MEGGERS MVCT. We do the ratio measurement on our already known current transformer. The test setup is identical and we start the test. The MVCT now wants to know via dialog box with which voltage should be tested. Here the user has to sync along and enter a value. Since we have previously determined the knee point voltage at greater than 11 volts, we decide for 10 volts, a test voltage that is slightly below the knee point. The test starts. We repeat the measurement 3 times and each time get the same result of 200 to 4.992 with an error of 0.167%. Here is a positive error issued. We expect it should have been rather negative. The angle deviation is displayed like this. Here we are not sure what it means. It reads like 0 degrees and 6 minutes, which doesn't make that much sense. In the manual we could not find anything and assume that 6 minutes are meant. But what happens if the user selects a voltage above the knee point as the test voltage? We just try it with 30 volts and run the test. The MVCT starts the measurement and now finds that we are above the knee point, and so no meaningful ratio can be measured. The test is cancelled and we receive the message: test voltage exceeds knee point voltage. Please enter a lower test voltage. An indication of where the knee point voltage is and which test volume makes sense is not shown. Here, the user must first perform the saturation test to determine the knee point voltage and then set a slightly smaller value for the translation test, no matter if you know it. It is easier if you test with the option Test All and activate the option for the saturation test. In this case, the test voltage for the ratio is automatically taken from the previous knee point determination and the user can relax. Also, with a CT analyzer, we can test with an unchanged test wiring and we start the test. The CTA starts immediately and automatically with the determination of the ratio by previously independently determining the knee point voltage, and from this determines a suitable value for the test voltage. For each of our 3 measurements we get the same ratio of 200 to 4.9643 amps with an error of minus 0.713% and an angle error of 10.29 minutes. Since a minute corresponds to the 60th part of a degree, this is approximately 0.17 degree. The CTA also gives very extensive results for the translation and phase angle deviation. Depending on the percentage rated current and with different design burdens, clear result tables are generated here. Since the results of the 2 devices deviate from each other, it was obvious to carry out an additional reference measurement. The only thing that we had within reach was our Compano 100 and a measuring shunt. We were able to determine the following results. The angle error delta was determined by the Compano 100 with 9 minutes. The MVCT provided 6 minutes and the CTA 10.29 minutes. The ratio error epsilon was determined to be minus 0.692 with the Compano 100, the MVCT was at 0.167% and the CT Analyzer at minus 0.731%. Let's come to the examination by PC. To control the MVCT as part of PC or laptop test, MEGGERS software flagship PowerDB must first be installed and launched. We settle for the light version and start the software. PowerDB is a universal software suite for a large number of MEGGER products. Accordingly, we need to locate and select our device type. The connection between the device and the laptop is made using Ethernet, and thanks to automatic device detection, the connection is set up quickly and without much effort. PowerDB now offers various options depending on the application and we select the ITMS module for CT testing. Now all test options and nominal data can be easily configured on the laptop and the test can be started. The progress of the test can be tracked on the laptop. The MVCT display shows a blockage message with the text Remote Control. At the end of the test, all results are automatically stored in protocols and can be saved and printed. In order to carry out the examination of the CT Analyzer with the PC, a small, slender software specially tailored for the device is installed. On the start page of the CTA, you now have the opportunity to use a quick test tool to address the test device, or you can use, as in our case, the Excel-based single CT measurement. Here too, the rated data of the CT can be conveniently entered and the test can begin. The test status is displayed on both the PC and the test set itself. After completion of the test, extensive and clear test protocols are generated and can also be stored or printed. Let's get to our last technical point, the green Meadow test. Here we can be brief and already clarify the following. Only with the CT Analyzer we were able to identify the type plate of an unknown current transformer. Although the MVCT offers a rating plate estimation in the options, the activation of these does not lead to the desired destination. For example, our 200 to 5 amps 10p5 current transformer was recognized as a 50 to 1 amps 5p5 transformer. The CT Analyzer, on the other hand, was able to determine all parameters of our test CTs without us having to enter even a single nominal parameter. For example, from our 50 to 1 amps split core CT. An important point when investing in a new test set is of course the price. We are not permitted to name the current prices in this video. A short request to the vendors will certainly quickly lead to the goal here. Maybe only so much. The prices of both devices are not far apart from each other. That's it again. Our conclusion is, we have here two incomparable products, each of which brings its own strengths. OMICRONS CT Analyzer is a high-precision, high-end instrument that truly proves it worth to a one-button test for uncompromising measurement of current transformers with all the know-how on board. Anyone who calls the miracle of Bern his own does not have to worry about the subject of CT testing. The MVCT from MEGGER, on the other hand, is broader in scope, and in addition to the classic current transformer tests, single-phase protection tests can also be carried out. The possibility of integrated isolation testing is a very useful feature in current and voltage transformer testing, although we have not explicitly tested it to our extent. The graphic design of the MVCT is world-class. Due to the large color display, the animation of the demagnetization process is really made for the movies. With the MVCT, the user should have some know-how. The number of optional test parameters must first be understood. In addition, for the German market, one or the other translation has to be increased.
If you liked our video, please press now the thumb up button and subscribe to our channel. See you next time and have a good one.